Karl Weaver. So Karl drove all the way down from Seattle today. Much appreciate Karl doing that for us. He's got a very interesting presentation today on mobile device payments and security around that. Karl he's a mobile device ecosystem and business development executive. He's globally trained and bilingual in Chinese. He goes to China quite frequently, I believe. He'll be telling us about that. He has a lot of experience selling wireless and mobile device technologies from both sides of the Pacific Rim to the global OEM, ODM, handset, tablet, PC supply chain. What is ODM?
Original design manufacturer.
Original design manufacturer, okay. And he recently spent 5 years working in China for Gemalto as a rainmaker for design of embedded mobile NFC payments and TEE security technologies to the OEM smartphone, tablet, PC ecosystem. So welcome, Karl.
Thank you.
Karl, I just hit the down arrow there.
Who here has a BlackBerry? BlackBerry phone. Not what's in your refrigerator. Who here has a BlackBerry? Does anybody have one here? Yes? Does anybody have an iPhone here? Interesting. So good afternoon. It is afternoon. My name is Karl Weaver. I'm a wireless market mobile device specialist. I'd like to thank James and the ISSH for inviting me down here to give a presentation. But the fact is, I'm also giving a presentation at the Microsoft store on the very same topic at 6 p.m. So I want to be the first one in the country to give a presentation on the same day in 2 different states. Yeah. And I'll probably accomplish that. So again, my name is Karl Weaver. I'm a wireless market mobile device specialist. I spent my entire professional career promoting mobile, PC, telecom, and wireless technologies, convergent technologies, to the Chinese and the Asia Pacific region. I started my career learning Mandarin Chinese under scholarship from the Taiwanese Ministry of Education. I studied Mandarin for 3 years, and I worked in Taiwan for 7 more years, total of 10 years in Taiwan. I'm originally, you notice the accent. Oh, good, yes, I do have an accent. I'm originally from Massachusetts. That's on the other side of the coast, And I basically have spent 20 years in the Pacific Northwest, in the Seattle area, helping wireless companies sell mobile technologies after spending 10 years in Taiwan. Fast forward, 2008, I was at the CTIA show giving a presentation on mobile WiMAX smartphones, because there's only one company, HTC, doing such things. And WiMAX, well, we all know via Intel where that went. I was at the event and I was giving a presentation, and there was some people from Gemalto in the crowd, and I said, what? Did you say gelato? I didn't know who Gemalto was, although I've been in the wireless business, not so much on the carrier side, more on the device side. So Gemalto talked to me after my presentation and said, we need a guy who can go to China and promote to the manufacturing ecosystem this thing called NFC. I said, what is that animal? This was 2008. I'd seen it once in Hong Kong. In 2007, Nokia were promoting this ugly feature phone along with Visa. And so they basically touch a point of sale device and say, is that cool? I said, what the hell does that do? Excuse my French. And then, of course, well, Gemalto is a French company. Actually, they're the leader in digital security. They basically said, we need a guy to go to China to promote to the handset manufacturing ecosystem, because the MNOs, the mobile network operators, were not cooperating with the handset vendors. Oh, what's that all about? I came in and I had to crack the chicken and egg between handset manufacturers and operators. They would not work together with this technology. I came in and I basically enabled that technology on every single mobile device except the 2 fruit-sounding companies, which I mentioned earlier. It's very, very interesting about those two fruit companies. Because 10 years ago, there was no Apple iPhone. 10 years ago, the best enterprise security was coming from a BlackBerry. 10 years later, and I can say this, some of the best security is coming from Apple. 5 years ago, Apple had little security, but we'll talk about the evolution of a BlackBerry to an Apple and absolute excellent mobile device and enterprise security to evolving important security on the iPhone. So it's really an evolution of fruit. You could say that. Now, if you look at the mobile device, and if you look at the entire manufacturing ecosystem, what we have here is the silicon chip vendors, which we don't really talk about much. Oh, but you're in Hillsborough, so bingo, you've got lots of chip vendors. The chip vendors sell to the handset manufacturers. The handset manufacturers sell to the MNOs. The MNOs get the mobile devices into the market. But actually, it's just a tool. The smartphone is nothing but a tool for the operators to make ROI, money. The operating systems actually go with the mobile devices, and there are 4 major brands. But I want to tell you that there's a Chinese company called Alibaba. You probably heard of it. They put an office in Seattle recently. They actually have what they call Aliyun OS. Some say they just ripped off Google. Lord knows I don't want to get into politics, but that's another operating system to watch for coming down the pipeline. Anyway, these are the other major vendors. Apps developers, apps marketplace, value-added service providers, all of these sell the technologies to the MNOs and all of their solutions to the MNOs, which get into the market. But here's the big problem. Security breaches all along the way. From the chip to the software. We recently heard that Apple malware was introduced via code that was used to develop iOS applications in China. Well, hello, Houston. We knew that problem was going to happen eventually. So it's interesting how Apple just discovered that this might be a problem. Well, I'll tell you a lot about this stuff down the road. This presentation is cool because it's about payment and security. You can't have payment without security. Nobody will pay for security unless it's connected to things like payment, DRM, protection of MP3s, MP4s. It's fact. It's a fact. So I call this, we can't quite see it because there's something on the top there, but I call this the mobile device holy grail for mobile payments. And what I mean by that is, first we heard of Apple Pay. Cool, yeah, it just works. It also has great security. I'll talk about security in a moment, but up here we have Apple Pay. We have something called Google Pay, or basically Google Wallet, which is from 4.4 on using what we call HCE, host card emulation. Okay, stick to that topic for 1 second. Let's migrate over here. We've also got something called Android Pay. And my goodness, Android Pay has been in the news 1 year, and they still have not told you everything that they're planning. We just heard an announcement that it's going to be person-to-person payments via Android Pay. But Android Pay hasn't completely told you all of the facts and everything that they're doing. Interesting. Let's come down here to PayPal. PayPal is not necessarily proximity payments. It's more online payment. Bitcoin. Bitcoin will use NFC technology and be more secure. Bitcoin, blockchain, cryptocurrencies are on the way here in the United States, and they're actually gaining popularity in the UK as well. Let's migrate over to Alibaba, which is not from the Middle East. It's Jack Ma, it's Alipay, it's Aliyun OS. It's basically the Chinese saying, well, we can do an operating system, we can do a smartphone. But Alibaba cooperated with a company called Meizu, which is just a handset manufacturer in China that they invested 5% in. And basically they're promoting their Alipay, which is a mobile wallet for proximity payments. That proximity payments can be barcode, but the Chinese government banned barcode, so they migrated to using NFC. They banned the barcode for payment, but not barcode for other things. Okay, barcode is not secure. So as you can see here, I say spin the wheel. And oh, I'm sorry, I forgot another really cool technology here. Samsung Many of you have Android smartphones. Samsung has NFC, and they have been. I worked a little bit with pushing Samsung to adopt NFC. They're a reluctant leader in NFC. But they also have something called MST. I think they call that magnetic strip technology, et cetera, et cetera. This is really cool, and you're going to experience this. Basically, when you take out your credit card, right, it's kind of a hassle. I have to take it out of my wallet. Wow, how much time is used doing that? I have to take it out of my wallet and I have to swipe, right? That's normally how you would do oh, look, I have chip and pin. We'll talk about that in a minute. But actually what Samsung did is they bought this technology from Loop. And Loop had this MST technology, which is actually the ability to take that magnetic strip technology and embed it in a chip, and that chip put on a smartphone, so that now, like NFC, all I have to do is take my handset next to the point-of-sale devices, new point-of-sale devices, and it works just like NFC. And I don't need my credit card anymore. Well, NFC does the same thing as this Loop technology, but we all know credit cards or magnetic strip credit cards are kind of going away. They simply are. So it's interesting what Samsung has done, but there is something called Samsung Pay. We have Apple Pay, we have Samsung Pay, we have Google Pay, we have Android Pay, we have Alipay. It's very, very interesting what's going on. It's good timing for everything, but I've kind of put it all together here to explain, and by the way, you're very welcome to get these slides. Just remember to give me credit for it because it took a while to put them together. Look at the situation we have. This is the global standard for mobile payment, which is using the SWP, which stands for Single Wire Protocol, NFC, SWP, NFC SIM card that you put in the smartphone. There was a company called ISIS, which is not a cute Egyptian lady. ISIS was basically, well, we know why they changed the name. They changed the name to SoftCard, right? SoftCard basically looked like they were gaining traction, but suddenly they went bankrupt. They went bankrupt at the end of last year, and we didn't hear much, and all of a sudden, there's an announcement. Google buys SoftCard. What did they buy? There wasn't much told. There still hasn't been much told. But there's some interesting stuff coming down the pipeline, I perceive. Look at the situation. This is the way normally you handle a SIM-based mobile payment, normally from SoftCard. And basically, every operator in the world uses this as the global standard to make a mobile payment on a smartphone. It's NFC-based, NFC SIM card based. You have to have an NFC handset. The mobile network operator takes the ownership, the control again by the MNOs. You can have multiple applets inside the SIM card operating, and there's no tokenization, at least not yet. There's no tokenization in the global standard. Who sets the global standard? A number of organizations, the GSMA mostly. Let's migrate. Apple Pay, cool, right? Who owns it? Apple owns it. Apple owns everything connected where their ecosystem is closed. The scheme, the controls from Apple. The multiple applets are coming from these guys. And the tokenization, yes, bingo. Apple provides a token. It's really card not present, but Apple provides a token so that even if you were somehow able to steal the token in Apple Pay, what are you stealing? Something that you cannot use. It's only useful at the point of sale, by the point of sale vendor. Let's go to Samsung Pay. This is what they're doing in Europe. This is what they're planning for the United States. It's really cool. Again, I mentioned the loop technology is really, really interesting. That's going to go, the credit card's going away, but right now I think Samsung has really done a very smart thing, which is to make everything seamless on the handset. So you never have to take the credit card out, yet you have the value of using the credit card as well as NFC with providing your credentials for a wallet with NFC, but also this MST technology. Let's go here. This is interesting. We have Android Pay. I talked to you a little bit about that. We also have host card emulation. What is host card emulation? A company called SimplyTap sold the technology, their SDK, to Google to use on KitKat 4.4 OS and above in 2013. 2014. And basically that's what we have. We have a technology which is nothing but software emulation. Does anybody know what card emulation means for NFC? NFC has 3 modes. I'll talk to you about that in a minute. Card emulation, peer-to-peer, and read-write mode. That's what NFC does. And that's basically for the SIM card, but HCE basically avoids using the SIM card with the payment credentials, reroutes it to the CPU, and then on to the cloud. We'll talk a little bit about that in a moment. Card emulation, bank delegated control solutions. The banks love this stuff. The operators are paranoid. They don't know what to do about it. And then you have the tokenization. Tokenization is important. Now finally we have Google Wallet. What is Google Wallet? It's a wallet you can download on any Android device. Maybe not just Android now, but it's a wallet you download. What's happening is these three technologies are what's going to be called Android Pay. Right now you have Android Pay, not really announced. We have Google Wallet, and then we have host card emulation. All of this is together. This will be the evolution of Android Pay, I believe. What's missing is the security of Android Pay, of the Google Wallet. What's missing is the security. Once you take the payment credentials and you store it into the open operating system, which is what host card emulation does, where's the security? There is no security. It's not tamper resistant. Hello, Houston. We got a real big problem here. But I perceive what we might hear. I'm going out on a limb now. What I perceive, what we might hear from the operators is that they've decided to allow the Google Wallet of the Android operating system to be embedded either into the removable physical SIM card, or they might cut a deal with NXP. NXP is the former Philips that is the co-inventor of the NFC technology, along with Sony and Nokia. It may be embedded into an embedded controller chip on the smartphone. We don't know yet exactly what they're going to do, but the interesting thing is you're going to find the tamper resistance somewhere in NXP's chip. That's what's going to happen. That's what I perceive to be happening. I think the operators are happy with that. I think that they spent lots of money with ISIS and then Softcard, and they didn't have any return on their investment. It was a real embarrassing thing in the United States, where lots of other countries around the world are doing mobile payments and doing it quite successfully. Europe, Asia, Japan, Korea, China, Taiwan. So it's very, very interesting. We want to let the world know that we're not laggards with mobile payment. This is part of the reason why I give this presentation. Let's migrate to, I think when we talk about payments and security, we have to get down to the very basics, which is, what is a smart card? It's a silicon chip. Why are the French, the Germans, and the Dutch controlling this technology when we Americans are the ones who invented semiconductors? Well, the European infrastructure on the front end wasn't as secure as the American infrastructure. We have great security on the back end. They didn't. But they decided to go with the smart card for credit card payments and all kinds of other uses of identity to verify things. So the Europeans actually took the technology from the Americans, and they started using and creating these smart chips. Schlumberger was one of the early adopters. Who is Gemalto? Who's Gemalto? Who knows who Gemalto is? Okay, Gemalto is a combination of Gem Plus, which was a French company, and Axalto, which spun out from Schlumberger. Gem Plus and Axalto merged in 2006 to be called Gemalto. It isn't an Italian ice cream. It's the global leader in digital security, all right? Basically, Gemalto makes the credit cards, the debit cards, and the SIM cards. If you ever wondered who actually makes those, it isn't the bank, it isn't Visa, it isn't MasterCard. It's companies like Gemalto, G&D, Obitour. These are French and German companies that actually have the technology that's used for our entire banking ecosystem of credit. Very interesting, isn't it? Now, when it comes to the secure element, though, all right, let me talk a little bit about these cards. You have an ISO 7816. That's the standard for these contact cards using the chip. But actually contactless. And by the way, has anybody ever seen a contactless credit card? Oh, they exist. Bank of America, US Bank, they're using contactless credit cards. Have you ever seen it? You've seen it? Not that common here in the United States. Very common in Asia, very common in Europe. Basically, instead of going to use your smartphone like Apple Pay to make the payment at the point of sale, you just use your card. It's helpful, it's useful, but essentially this can be done with your smartphone. So why do you need contactless? Well, American banks have been they've not implemented contactless as much as they have for the smartphone. Everybody's working on a mobile wallet. Every bank in America is working on a mobile wallet. But they seem to realize that I want the convenience with my credit card to do contactless. So the standard for that is actually ISO 14443. That's the standard for contactless, whether it be a smartphone or a credit card. That's the standard for contactless, set by the NFC Forum. Okay, so now we know what a smart card is, but, well, what's a secure element? A secure element is like a storage facility, a tamper-resistant storage facility within the credit card. It's software embedded into the hardware. That's what the secure element is. And Gemalto makes the secure element, but there are various form factors where the secure element can be put in. Again, embedded into the chip. This is what NXP is doing. In the SIM card, which is what Gemalto does, and everybody does all of these. And of course the micro SD. All the chip and smart card makers can put it in any various form factor. There's a company down here in Portland, Typhone. They're doing it in micro SD. Secure elements and the NFC architecture. Basically, there's a controller in the smartphone, a controller chip in the smartphone. There's a mobile wallet in the smartphone, which is NFC compatible. It could be barcode also, and low emission Bluetooth low emission as well. So it isn't just NFC. The wallets need to be compatible with various formats. They can be compatible with various formats. Protocol interfaces, a bunch of different protocols. Historical, okay? Historical. It wasn't just one protocol. It started 15, 20 years ago, the evolution of NFC technology. So there's a smart OS. All of these OSs use NFC now, and there's also the secure element has also a Java OS, but it's really about taking and storing things tamper-resistantly in a tamper-resistant solution inside of the SIM card or the micro SD or the chip itself, the semiconductor chip itself. An NFC handset basically needs an antenna. You have to design the antenna in the smartphone with the NFC chip. NXP is the leader producing NFC chips, but the, ST Micros, Inside, Secure, Broadcom, these companies also make NFC controller chips. And how it works is you basically design it to connect with the SIM card. The controller chip uses a connection called SWP, Single Wire Protocol, invented by Gemalto, which was made a global standard. The SIM card basically connects with SWP NFC to the controller chip. The controller chip in the smartphone touches the point of sale device to have, actually, what is it? Peer-to-peer encryption. Contactless mobile NFC. I mentioned before there are 3 modes in contactless mobile near. NFC means near field communications, not National Football Conference. Go Seahawks. Well, I guess here it's Oregon Ducks, right? Sorry. I'm not a football guy, I'm a baseball guy. Anyway, NFC Forum sets the standard for 3 formats used in near field communications technology. Question. What format is Apple using now? Who knows? What format are they using for Apple Pay? Does anybody know? Card emulation mode, of course, right? Credit card. You can see your credit card. That simply uses card emulation mode. It's emulating a smart card. Okay, so I talked about host card emulation. Normally, this is how you have the smartphone here, right? And the NFC controller, and it touches the point of sale device. By the way, it's master-slave. You have an NFC chip in the smartphone, you have an NFC chip in the point of sale terminal. That's how it works. This is normally the way that it works. In this scenario, they bypass the secure, I'm sorry. This is normally how it works. The secure element is in the SIM card, up here. Goes through the NFC controller chip for the point of sale device. Down here, basically, you don't need to go through the SIM card, and the payment credentials actually get sent through the controller to the mobile applications processor chip. So you're avoiding using the SIM card. Who doesn't like this? Mobile network operators, of course, they don't like this. Who hated this? ISIS/Softcard. What did they tell Google? You will not use your mobile wallet with our technology. They basically banned Google Wallet around 2014. They basically banned it. Why? Because host card emulation takes control away from the operators and basically says, well, now banks can actually develop their own wallet with their own onto the smartphone, and they don't need the handset they don't need the operators anymore. So, of course, MNOs, mobile network operators, wireless operators, they don't like that technology, but they have no choice because it's now on Google Android smartphones. But guess what? It's not just on Google. Actually, BlackBerry developed this technology called virtual target emulation in 2007. And who else has this technology? A small company in Redmond. Ever heard of this company called Microsoft? They've also developed this technology. I'll talk a little bit about Microsoft Pay, which is not official and not announced. And I'm presenting in the Microsoft store. So they told me, you cannot say that. Well, I'm here in Portland. Anybody here from Microsoft? I'm going to say that. All right. Now, I really can't see the top of the slide. It's the way I designed. You have consolidation going on now in the smartphone of today. Why? Because the SIM card from the operators is still taking precedence except for Apple, right? When you buy a smartphone today, except for Apple, the SIM card comes from the mobile network operator. Now, if it's Google Android, you can actually design the phone to work with the bank's wallet or with the operator's SIM card, right? Well, what's the evolution then? Here's the evolution. The evolution is a hybrid smartphone that works with the operator's network, because you need an operator in order to do wireless technology. No operator, where does the technology go? You need an infrastructure. So I believe that there's a revolution going on here with the hybridization of the smartphone to accept this host card emulation, especially in Google Android smartphones, but as I told you, not just on Google. I think everybody will adopt it. And then there's the MNOs who still prefer the SWP NFC SIM card for the mobile payment on the smartphones. So what is Apple doing? Well, Apple is the smartest of all these companies. Why? Because Apple has something called a soft SIM. And their soft SIM program, they're now putting into play on their iPad minis, okay? Basically, when you get the SIM card, it doesn't come from the operator, it comes from Apple. They're probably working with Gemalto privately or some other SIM card company. When you get the smartphone, when you get your tablet, it comes with a SIM card. You simply provision the SIM card with over-the-air, you simply provision the SIM card for the operator that you want. How simple does that get? It's quite nice for the consumer. It's quite terrifying for the mobile network operator. They don't like it. Apple will control its future and its destiny. That's how they're doing it. All the other handset manufacturers are celebrating, saying, how come Apple can do that? We can't. Samsung tried to do that. The operator said, I won't buy your handsets. HTC, I won't buy your handsets. LG, I won't buy your handsets. Therefore, any other handset manufacturer needs to rely on the operator buying their smartphones, putting the SIM card in there for mobile payments. So they don't want to upset the mobile network operators. Apple just doesn't care. They'll do what they want to do. It's a very smart company. They can take control. The other handset manufacturers also want to take control away from other chip vendors. They want to take control away from the mobile network operators. They want to control the destiny, but they can't right now. So therefore, this hybrid phone is very interesting because it allows them, I'm a handset manufacturer, it allows me to sell to the banks, mobile financial organizations, but I can also sell to the MNOs. So that's what I call this hybridization of the smartphone into a device that can please the banks and the operators. Because if you haven't heard about this, banks and operators don't get along. They haven't in any country in the world. They just won't. The transportation company, there are people here from TriNet. Where are you? Can you raise your hand? TriNet. TriMet. Cool. Have I said anything you disagree with? Now you transportation organizations, you're a bit more neutral. No, because you already have the network. No MNO and no bank is going to take that away from you. So you can actually play in this ball game because you can supply a mobile wallet with your credentials for the transportation system that you've set up to use NFC. You're working on that. You will be working on that mobile wallet. Is that correct?
SurePie is doing that for us.
SurePie. Cool. Do you need my razor? No, I'm joking. All right. That's a joke. Just trying to get you, I like to joke, okay? That's what my life is about. All right, so this is the traditional way. It's really complicated. This is the traditional way that you make a mobile payment with something called a TSM, a Trusted Service Manager, in the network. This is normally how you would do it. It's damn confusing, isn't it? You got the secure element there, that's the SIM card. You've got the mobile wallet. You take the handset, you touch the point of sale device, it goes to what we call a payment network. That payment network goes to 2 different banks, then it has to be provisioned by the service provider and the MNO. There are 2 TSMs. It's actually looping itself together. Woo! Expensive, complicated, and consumers say, I just want the KISS principle. Just give me the device. I don't care about all this security. End users don't care about security, except when it comes to payment. Then they don't want their credit card stolen. This is now being replaced by this. This is the approach where you basically have a host card emulation scenario, and the point of sale has host card emulation technology, and it goes into the payment network, and it goes to these banks, but it goes into the cloud, and it actually has a token service provider to provide a token. That token is providing for the payment data, and it goes back down into the smartphone as a token, ready to be used back at the point of sale. When you touch, a cryptogram is sent back to the point of sale sends a token. The token is not your credit card details, it's something else, but it still contains some information from the credit card to identify you. The point of sale device knows what a token is, and then it all basically works. The problem with all this technology is the mobile app is still in the open operating system. It's not tamper resistant, it's not secure. So who's going to secure that? Well, knock on wood, the hackers are just waiting for Android Pay to be announced, and it's the hackers more than anybody else who are waiting for Android Pay to launch so that they can try to steal and hack into it. It's very simple. How do you emulate a secure element in the cloud? It's a virtual secure element, that's what it is basically. How it works is, when you take the handset and touch the point of sale device, it's going into the cloud, it's provisioning in the cloud, and it's providing from the cloud, and that, by the way, Bell ID is a pretty good HC vendor. There are 4 different major vendors. I have connection with all of them. Simply Tap, Sequence Software in California, Bell ID over in Switzerland, and the UK as well. And then there's a company in Canada called Secure Key. Ever hear of these guys? These are the 4 major companies. There are probably a few others, but these guys have the IP, which means they can provide you an SDK. If you're a bank, they can provide you an SDK so you can develop your mobile wallet. Everything gets provisioned through an API back into the mobile handset in your wallet. It's not secure. It simply is not secure. It should go into the SIM card. I think that's what Google is going to do. I could be wrong, but I think that's what Google is going to do. Let me move on, because I got lots of slides. Again, we explain how it works. It goes through the cloud to provision a token. Various token suppliers can issue through the cloud back down into the smartphone. Google loves this. Banks like it, means they don't have to talk to the operators, but it's not secure. Even though it's a token, even if you can't use it if you're stealing it, it still means that important sensitive data can be stolen in the handset. And even if they're not using it to steal your money, they're going to use it for something else. So it's not good to have half a solution. It needs the security. I'll talk about that. Tokens. Here, your PAN goes through what we call a token service provider and then gets encrypted. And a token is created. These tokens look something like this on your smartphone. It's simply become a token. Your credit card details have simply now become a token, a very useful, almost like a token when you get onto the bus. It becomes a very useful thing that is exchanged for money. A token is exchanged for the credit card details. It becomes something else. Enough about that, because that can be really complicated and we don't have that time. It's getting late. Tokens will be are used by Visa, MasterCard, and American Express, but EMVCo is setting the standard for that and working with these organizations as well. Why? Because EMVCo manages the smart card technology that goes into the credit cards and even onto the smartphones that we're using for mobile payment. So it's a combination of the credit card companies plus EMVCo that are involved in providing the standards for tokens and, of course, for mobile payment. That was really fast. I'm sorry. That's a very simple explanation of that. It's not exactly as simple as that. But how does Apple handle it? How does Apple and Android handle a token? From the iPhone, basically, they go and obtain a token, and that there's a conversion to the card that happens before it gets sent down to the smartphone. It's a complicated process. The program token when a card is tokenized. It's a bit complicated. This is the process. But for HC, it's much more simple. It just comes from the cloud. A token comes from the cloud. So this is a very simple explanation. You engineers in the room are going to hate this marketing response, but that's it. Because I have too many slides. I didn't know. Does anybody want to know what's going on in China? Probably not. All right. But basically, that's where I come in that China UnionPay, which is a huge credit card issuing and clearinghouse for technology in China, basically is going to use postcard emulation as well. And basically, they're provisioning that now because they don't like working with the banks, the mobile network operators either. So we can just kind of... Does anybody want to know anything about this? I guess not. All right. So EMV versus Cloud Payment Cryptograms. The EMV technology handles the cryptogram a different way than Apple does, or than Android does. So a cryptogram in cloud-based payments is created half in the cloud, and then the other half when you tap the phone at the point-of-sale device. Otherwise, you could experience latency. Remember, this HCE technology actually works with wireless. So if you're in an area where you don't have the coverage, this is the importance of why half the cryptogram is made in the cloud, and the other half is enabled when you touch the point-of-sale device. Otherwise, you could experience latency issues involved with network connectivity. This offsets the relay threat in the app security and sensor-rich Android OS. So it's just important to note that there can be some issues if you have no connectivity when you're using an HCE-enabled smartphone on the Android operating system smartphone. So these are things to take into consideration. When I started to show this slide was last year, there were just a few companies part of Apple Pay. And all these guys were like, well, we're looking at it, but we're not really interested. And that means these were non-NFC solutions, because Apple Pay is NFC. After a number of months, and a year now, lots of these companies, and these companies were sort of on the border. Lots of these companies already migrated to use Apple Pay, and they will also use Android Pay because they both use the NFC chip in the smartphone to do proximity mobile payments. There are two types of payments. You've got remote payment where you access a browser, you pull out your credit card, and you pay from a browser, or even the wallet. You pay with your credit details. We call that remote payment. Proximity payment is at the point of sale, with your barcode, with your Bluetooth. Normally not Bluetooth, but normally with your barcode or with your NFC technology. You're at the point of sale, and you make a payment with your smartphone. That's what we call proximity mobile, or near-field, or contactless mobile payment. Now let's go to the security. You're all security people. Now we're jumping into security. But I had to get to the payment. Thank you very much for having patience with me. You like this guy here? This is a hacker. Now, I hate to say it. How many software people do we have in the room? Okay, let's be honest. Let's be honest. You guys are some closet hacker. Some closet hacker in innuendo, not the right word. You have hacked in your life, have you not?
Never.
It's only hacked if you like to trace it. That's why it doesn't work.
What? Seattle Times? They want to hear from you. All right. The basic thing here is that hackers around the world I think they started out as good people, but they simply got corrupted. It's like an opium, basically. Much like buying cheap Chinese-made products. It's an opium that we all do. Let's be honest, huh? Let's be honest, all right? It's a fact. Now, hackers are involved and have very sophisticated tools to steal information from us. I'm focusing my presentation on mobile device security and the problem of hackers on mobile devices, because people care about making payments on mobile devices. If you look at the situation, there's lots of SMS messaging that is being hacked right now. So your online banking, whoa, be careful if you're using SSL. Mobile adware, well, it's really interesting and it's cool that Google likes to promote with advertising its business model and its profits. I got to tell Google something, I need to tell Google something. Apple doesn't do it that way. Apple truly believes that your privacy and your security matter. Apple truly believes that. I believe that. I know BlackBerry does, okay? So I use the Apple and the BlackBerry scenario because those are sophisticated devices. And by the way, they're the only American or North American companies left manufacturing smartphones, although the smartphones are actually made in China. And they have the great levels of security. We won't be able to do anything on our smartphones in the very near future unless we can guarantee the security. Because, hello, we all know the breaches that are occurring. Lots of information is being stolen. There's lots of bank fraud, ransomware. Oh, ransomware is really cool, okay? So somebody puts malware or a Trojan into the operating system or into the application, you download it, you have it on your smartphone, and then they call you up and say, hey, by the way, your smartphone doesn't work anymore, your PC doesn't work anymore, but I can magically remove it. Oh, by the way, if you don't pay, your device will never turn on again. They're blackmailing you. There are lots of botnets, and of course there's lots of spam. Thank goodness we have a spam folder from Microsoft. Well, I think Microsoft is finally got the point that they will not sell their Internet Explorer anymore unless they improve it. Hell, it doesn't even exist anymore. They're using Bing, right? So the key point is security, 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 and a lot of people forget it, and end users don't care about it. They simply don't care. They don't care because, well, it costs money. It costs lots of money to protect. Here's the problem. We have to isolate from the open operating system. I know that lots of Google Android users say, I want my freedom. I want an open operating system. Can't happen that way because we have cyber criminals. We have hackers. We have terrorists who are software developers. We have all these things in the world today. So your touchy-feely open operating system, I'm sorry, it isn't going to work like that in the future. We have a huge problem in this country. Even our insurance companies are being hacked. Our Social Security is being hacked. Yeah, hacked. Yeah, you might want to say it's just the Chinese, maybe it's the Russians. Well, the NSA does a little bit of work very successfully as well. I don't want to get anything more into what the NSA does, but I'm glad and I'm thankful that at least they have good technology. The key is that nobody trusts anybody anymore because we have no security on our mobile devices, and I'm here just telling you that the technology exists to stop all this, but it costs money. So forget the end user, they won't pay for it. The leadership has to come from the mobile network operators, from the handset manufacturers, from the OS manufacturers. They have to take the leadership. And finally, the programmers and the developers. I envision one day a United Nations of applications developers or apps developers have their whole platform for trusted computing apps. I believe that it has to happen like that because we cannot trust that our application has or hasn't been infected with malware, Trojans, viruses, etc., etc. You just can't today. Look at Apple's situation. And Apple cares about security. But they just expected that the Chinese code developers would download the code from their site instead of a third-party site that put the malware, embedded the malware into the developer tools that they use to make applications. Who's at fault, really? So the problem we have is that software-only solutions at the OS level, they're not secure. OS itself, it has lots of flaws. You just call Microsoft, they'll tell you everything's great. And hardware, firmware, and the OS can all be modified. Hardware attacks required to be countered with hardware protections. So what it's all about is this thing called the TEE. Has anybody ever heard of the TEE? Anybody? All right, the TEE stands for the Trusted Execution Environment. But the history of the TEE goes back, way back to Microsoft and trusted computing modules, actually, over a decade ago. That's very, very interesting. But what it is basically saying is that my open operating system is not secure, simply not secure. So I need to take sensitive applications, or any application, and I need to port it over using global platform, standardized APIs, into a secure environment in the mobile apps processor chip. Every single mobile device that we have in the world today is powered by a mobile apps processor chip. That's where you get the app processing from. But it also has a storage facility in the chip called Trustzone from ARM. ARM controls about 92 or 93% of all the wireless platforms in the world for chips. Of course, Intel down the road in Hillsboro, they have about 7 or 8% of the wireless platforms in the world. But basically, it's ARM. ARM has created something called Trustzone. Trustzone creates a security firewall apparatus in the chip. It's almost like an apartment that you can rent and do something in. You take your application from the open operating system, you bring it through and port it using global platform standard APIs into this firewall environment, and then you process things like DRM to protect MP3s and MP4s. You process things like the mobile payment transactions that occur, all being done in a tamper-resistant hardware in the chip that hackers cannot access because it uses cryptographic keys. And that's what, and basically that's how you get it in, it's encryption. Okay? It's encrypted. All right, now these are hacks that can, these are attacks that can occur from the software level side and the hardware side. Yeah, you see they can actually attack it when it goes between the processor and the memory. So hackers are very sophisticated. They can get to it even from the hardware side if you don't protect it. Of course, software is not protectable. So you have exploits. You have software attacks and hardware attacks. These are going on every day. They say that 10,000 malware programs are created around the world every day. Wow, who can keep up with that? What is it telling us? It tells us that hackers make more money than drug dealers. Okay, this is a very serious problem. And it also tells us that the opium is there because I can do a malware program, sell it to you, he sells it to somebody else. I'm almost scot-free. You'll never catch me. Gives the FBI, the CIA, gives them nightmares, okay, with what's really going on. Let me go back here. All right, yes. So what do I do? Well, I'm the NFC and I'm the TE rainmaker because I enabled these technologies in the Chinese world before I came back to the United States in 2013. I enabled these technologies in greater Chinese world, working for Gemalto. The near-field communications I enabled for the payment, and then they put me on this TE, Trusted Execution Environment Technology. Gemalto had bought a company called Trusted Logic, which spun out to a three-way JV called between ARM, Gemalto, and G&D, two chip companies and one platform vendor. And basically, this technology, the TE, is in every single, or the Trustzone technology from ARM is in every single mobile applications processor chip. It's even in Apple's A7, A8, and A9 chips. And Apple made its own version of this TEE for their smartphone right now. So if you want to know about Apple's security, it's very secure. Google is getting there. The real key is the way to protect your mobile application is in the firewall of a chip. And then you get the keys, cryptographic keys, to get access. Of course, that costs money. So security is not free, security costs money. And if you think hackers won't steal your information, you are definitely wrong. So security is moving to hardware. It's moving from software, passwords. Who wants to store a password? Better to use your biometric thumb or your retina. Some say your heartbeat, right? The EKG. That's coming. Legacy online payments, signature authentication. These are all software. It's moving to embedded security chips, stored payment credentials in the chip, in the smartphone, and hardware encryption. That's where we're moving for security on smartphones. Security gets built in. I work for a company now called Rivetz. Rivetz designs developer tools to enable TEE applications. Bingo. You might say, well, where are all these TEE applications? Where do I see them? Well, there's a company called T-Mobile. T-Mobile has adopted them for something called SIMlock. Just one of the use cases for the TEE that's being used in T-Mobile right now. That's not, for some reason they haven't made this public, but T-Mobile is one of the early adopters of the TEE technology in at least 7 Chinese-made Android smartphones, and not just Chinese. Samsung, LG, all have this technology. So I asked T-Mobile, well, why don't you tell the public? Why doesn't the handset manufacturer tell the public? I have all this technology. Well, Samsung kind of calls it NOx. Have you heard of this NOx technology? Well, that's what it is. It's security in the TEE. That's what it is. But for some reason, MNOs and handset manufacturers don't want to tell the world that smartphones can be breached. And so it's kind of like a chicken and egg. You want to tell them you have great security, but you don't want to tell them that actually if they don't use the security and if they don't implement it with applications, then, well, you're not protecting anything. And nobody wants to tell you they had a breach. No bank, no operating system vendor, nobody wants to say that they've been breached. They've all been breached. They've all been breached over the years, every single one of them, and yet they don't want to say anything. I think that they need to say things now because guess what? This guy, Edward Snowden, anybody know this guy? Basically, he explained that we have no security, nobody trusts anybody else, and that is kind of the problem that we have in the world today. Fortunately, though, we have a technology that's already on the smartphones, and it isn't being used. Why? Because security costs money. We provide unbelievably dirt cheap technology in the form of an SDK for any single apps developer to develop their app to use in this TEE. Isn't that cool? That's what Rivetz does. That's what the company I work for does. Why did they hire me? Well, not because I'm a charming individual. I think it's because I have the knowledge of the payment and this TEE technology, and that's why I was hired to help them evangelize this technology to the developer community. That's one of my roles, is to evangelize this technology to the developer community. But basically, the security is getting built in. We're helping to do that. Rivetz is supplying the TEE to at least 10 Bitcoin vendors right now. Oh yes, Bitcoin vendors are going to continue to evolve this cryptocurrency technology. But it's not secure unless you put it inside the TEE. So the key is this trusted execution environment technology is really cool. It's already in every single smartphone, but nobody's turned it on. And where are the apps? I only saw the T-Mobile app for SIMlock. That's number one. And then I saw Huawei, which is a Chinese smartphone manufacturer, has implemented WeChat. Anybody know WeChat? They've implemented WeChat inside the TEE, which is kind of cool. But their TEE doesn't come from the company that developed the TEE, Trustzone, which is the three-way JV. They developed their own. Qualcomm is developing their own. All the chip vendors are developing their own. You can, because it's an open, ARM just cares about, what do they care about is their security. And if you comply with their requirements, then you can make your own TEE as well. So the great thing is that security in the form of tamper resistance in the chip is coming. All the smartphone vendors are adopting it. Companies like China UnionPay, Alipay, they're all adopting it. The banks, the transportation companies, even the MNOs know the importance of the TEE because the SIM card is simply going away. It's simply outused its usefulness. It's been around 30 plus years, the SIM card. It's simply going away. So the key here is that this technology exists now, and we're providing developer tools for this. Modern transactions require secure instruction. Yes, we just talked about the need for safe key storage, backup, secure processing, secure display. Even the biometrics need to be secure. Now, here's how Apple handles biometrics. They have created their own TEE, Apple has, and they are working with ARM for Trustzone. So the biometrics algorithm for your thumb gets stored into the TE and only called up when you make the transaction with the payment. So hackers can't get to it because it's stored inside the TE in the chip. It's actually stored there. How does Apple handle the payment credentials? They store that in the embedded secure element from NXP. So hackers can't get to the payment credentials, they can't get to the biometrics authentication either. That's why the Apple iPhone is now very, very secure. Or at least I think it's pretty secure. It's very, very interesting stuff. Let me move on.
About 5 after 1.
5 more minutes? Okay.
Maybe 5 more, maybe?
Yeah, we're almost finished here. As I talked to you before about this technology, it's basically taking rich operating system applications and putting them inside Trustonics TE, which with inside ARM's Trustzone. So ARM makes the chip and the security called Trustzone. Trustonic makes the software. It's a software security OS inside the chip. It's kind of how it works. We supply the applications and we get them from the open operating system into the TE. That's what Rivetz does. Trustonic does the same thing. But it's really the fact that there are very few apps out there. So that's what we want to do. We want to enable apps developers to develop using our simple tools for this solution. So that's why we have the capability to protect display, storage, secure PIN entry, encryption and decryption capabilities, and even biometrics. And we can provide all these type of solutions for all these type of applications. That's what Rivetz does. That's what I am here telling you about. It's because there's so many different applications that need security. And a little bit about biometrics, which is really important. You know, what's very, very interesting about biometrics is when I can know, almost beyond a measure of a doubt, your thumb, your retina, your heartbeat, when I can know that it's really you, think about this, why do I need a credit card? Why do I need a credit card? I'm me, I have money in the bank. So biometrics are actually a destructive process where you now become the key stakeholder in your own finances. I'm me, check me out, here's my thumbprint, here's my retina. I want to buy a car, I have the money in the bank. Why do I need a credit card company? So biometrics actually is going to evolve and allow you that capability because it's you and you have a way to validate that, and it's not with a smart card and it's not with a chip and pin signature. It's you, okay? Just think about that for the future. These are just some biometrics definitions. I won't get into them because we're running late. But I wanted you to think about how biometrics are creating this destructive innovation actually as well. It's very, very interesting. My summary is too damn long, isn't it? So I'll just wind up by saying, for payments you need security. I really wanted to get an Apple iPhone from a crowd participant, from the audience, and a BlackBerry, and I wanted to say that the BlackBerry was last year's security, because you don't even have a BlackBerry anymore. Everybody has an iPhone. The iPhone is this year's security. So that was really all that I wanted to say. There's me. If you have any questions, you can have my PowerPoint presentation if you find it very, very interesting. You can see lots of my videos on YouTube. I've got at least 30 or 40 presentations on YouTube. And in China, I have them on Youku, which is a Chinese video streaming website, because the Chinese ban YouTube, Facebook, and Twitter, and Google, anything Google. So you have to figure out a way to get your technology into the Chinese ecosystem. So that is my presentation. Yeah, that's a smartphone. That's a BlackBerry.
That's you on WeChat.
That's me on WeChat. Encrypted. Thank you very much. I hope this was enjoyable and interesting for you. I know it's complicated stuff. I tried to filter it and bring it to the KISS principle so that everybody could understand. The security is coming. It's there. So don't feel like the world is trying to kill you, because the security is on these devices. It's just a matter of time to implement it, and we need secure applications. Thank you.
Thank you, Karl.
Thank you.
Any questions quickly for Karl?
Yes, any questions? I'll be very happy to take them.
So, the TEE, can you, do you guys have plans to make that SRAD or PCI, things like that?
The TEE
Yeah,
is already, we didn't invent the TEE, that
Okay.
was invented by Trusted Logic and actually spun out to a three-way joint venture called Trustzone now. Those are the owners of the TEE. But the TEE can be implemented and tweaked, and a similar solution. Intel has a so-called TEE competitor. Qualcomm is making a TEE competitor. NVIDIA. The TEE is just what Trustzone can use as their trademark, but everybody will be making a security OS that goes into the ARM Trustzone. Everybody will be doing that. We, as Rivetz, can work with any of those competitors because we're simply providing developer tools that anybody can use with all of these versions of the TEE because they're all standardized in Global Platform. Global Platform standardizes the secure element and the TEE. So it's Global Platform that standardizes these technologies, actually. Yes?
Since you're recording this, are you going to make the video available, the presentation?
Did you want to come up and get your 10 minutes of fame as well? Come up and...
No, I just, actually...
I will be capturing it. I will be putting it up on YouTube. I put all my videos up on YouTube because that's really important to stamp your identity in history. Not enough people do that. I've been doing that for over a decade. Do you want a copy of that, or do you want to see it on... You know, if you want to talk to me, I'll give you my business card. I have them right here. Don't be afraid. I don't know. I don't think I answered your question, though.
so can I add you?
Please go ahead. Please go ahead. I don't know if you're Hacker Central. I don't know, but it's okay.
I'm a hacker, you already said that.
No, I don't know. You could be one of those ethical hackers who's out to catch those nasty hackers because there are lots of them. Now, I'm very happy to connect with you on LinkedIn. What is your name?
William?
Hi, William. Very happy to connect with you on WeChat. WeChat is a great program. Unfortunately, I don't know if it's safe. But when you put it in the...
payments over there too.
Right,
Yeah.
right. So actually, WeChat needs to go in the TE, doesn't it? And I'm actually working on that right now. Any other questions?
Thank you, Karl. That was a really good presentation.
Yeah.
Was it good?
Yeah.
It's a lot of terms, but thank you.
Want to make a really quick announcement. B-Size PDX, it's a local security convention. We go into really deep detail on